So there's this interesting number that comes up in dealing with the natural world, and it pops up in calculus a whole lot as well. But it's this right here, the limit as n goes to infinity of 1 plus 1 over n to the power of n. Now, that means probably nothing to you at this point, but ultimately, as n gets really large, and we plug in the values, really large values for n to there and to there, as the numbers get infinitely large, the value of that statement settles in on this. Now, this is an irrational number. Think pi going on forever. It's that type of number, 2.718281 dot, dot, dot. It's a non-repeating, never-ending decimal, irrational. And it pops up in nature a lot, and then it's using calculus a whole lot. And so you're going to see it here. Mathematicians use the symbol E to represent this constant. A little bit less than 3, ugly number. Now, what you have to know is all E is a number. It's just a number. An ugly number, but it's just a number. So if I say log base E of x equals y, that has the same meaning that it had before. If I said log base 2 of x equals y, which we've seen before, that's still 2 to the power of y equals x. The only difference is these are two different numbers being used as a base. One is the symbol e, which represents the 2.7 whatever, 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 and the other is just a nice neat 2. But you will see e used as a base regularly. So just remember that e is a number, just like the other numbers we've used before. But I am going to change one thing here. So we say log base e like we say log base 2. But in the math world, it's conventional to not write log base e. It's actually the convention to write ln. And I forget the exact pronunciation, but it's like a Latin pronunciation of log natural. Ln is log base e. And so I just want you to see this. If you have log base e, that is the equivalent to ln. Just the ln, the abbreviation comes from a different language. I believe it's Latin. So you will see ln. So if you see ln of x, the equivalent, natural log of x, and it's pronounced natural log of x, that's how you would say that, is equivalent to log base e of x equals y, and both of those are e to the power of y equals x in its exponential form. So just be aware that you're going to see this used a lot, but it is in fact the same. It is in fact the same thing. Now, and I say other ugly logs because log base e is log base 2.718281 dot, dot, dot. It's ugly. There will be a lot of situations in dealing with logs where you have ugly numbers, ugly answers. And so I just want to make sure that you're aware that we sometimes get ugly numbers. So if I have the natural log of 2 equals x, if I rearrange this, I have e to the power of x equals 2. Well, hopefully it's clear to you that e, 2.7 whatever, 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 to some power equals 2. That is not going to be nice and neat. It is not a nice, neat power. So there's good news and bad news about this. The bad news is it's really ugly. The good news is we wouldn't actually try to figure it out. We would actually just leave it right there. We would simply say x is the natural log of 2. Whatever that is, natural log of 2. You can punch it into a calculator and see what it would give you. But it is going to be an ugly, irrational number. We also sometimes see ugly, irrational numbers pop up in things like 3 to the power of 2x equals 5. Now, in this case, 3 does not have a nice, neat power that gives us 5. It doesn't. But if we write it in its logarithmic form, so log base 3 of 5 equals 2x, we basically do what we did right up here. We were like, oh, this is too ugly. This doesn't have a nice answer. I need a calculator to get a decimal equivalent. And so what we do is we simply say, okay, fine, calculator it is. The answer is log base 3 of 5 divided by 2. And we would say that is a mathematically perfect answer. I don't know what the decimal equivalent is. We could plug it into a calculator to find out, but I'm good. I'm good leaving it right there. So understand that there will be times when it's not possible to get a nice, neat number, whether it's because we're dealing with E, which is this super ugly thing, which by default is super ugly, or whether we actually have relatively friendly numbers. That's not scary looking, but the answer is going to be horrendous. So whether it's by default because of using E or it just works out that it's not a nice, neat answer, we will sometimes have problems that we leave in its logarithmic form because that is really as precise as we can make it. So understand that those types of problems will happen sometimes, and that's okay. I'm going to do one more example. Number 111 from page 476. But it is 5 times e to the power of 0.2x equals 7. There is all kinds of ugliness existing right here. All kinds of ugliness. So the first thing I'm going to do is I'm going to divide both sides by 5. And I have e to the power of 0.2x equals 7/5. Now, when I look at this, I know full well this is not going to work out nice and neat. So in this situation, I actually want to put it into its logarithmic form. So I'm going to say natural log, because it's going to be log base e of 7/5 is equal to 0.2x. That's where I'm at right now. Now, I don't want 0.2x, I want x. So I'm going to divide both sides by 0.2. And I got x equals natural log of 7/5 over 0.2. That actually is what my answer is. That's the answer. So it feels a little bit weird. It feels like we're kind of cheating, and we are to an extent. But these are problems that don't have nice, neat answers. And so that's how we leave them. Reach out when you have questions. This stuff is a little bit crazy. Email me. Happy to hop on WebEx with you and discuss it further.